We're in Perkins, Oklahoma, July 30th, 2012, looking at the soil acidity impact on sesame. As we start looking at the crop, we're going to walk in from a pH of 7, and we're just going to walk down as a pH range. So we're from 7, we're at 6. We're moving into the 6.55. We're just now looking at the pH of 5 plot. As you see this stand start to disappear, we move into the 4.5. Now you're looking at 4. We're going to go back up again. We're still looking at 4. Now 4.5. See the stand start picking up. We're moving into a 5 and 5.5, 6, and now 7. So as we see that even as all the other crops we've seen before, we have dramatic impact on stand and growth. Another shot, you can see a pH of 4 right next to a pH of 7. The pH of 4 is on the right hand side, the pH of 7 is on the left hand side. You see the significant difference. Right next to the 7, just to the left a little bit further, is a 5. And then we go down to another 4. That range of 3 pHs right there tells you quite a bit of a story about how soil pH impacts crop and crop production. One last note, I want to make a point of showing that we have two plots right here. We have a pH of 4 and a pH of 5 side by side. You see the plants are still pouring the 5, but what I want to point out here is not necessarily the plants. Look at the amount of residue in the 4, which is on the left hand side, versus the 5, which is on the right hand side. The 4 has a much greater amount of residue on the surface because of the pH is impacting our ability to control weeds. At that low pH, we have a real hard time controlling weeds and having any herbicide that has activity long enough to keep it good. So you can see a difference on the left to right of just on the residue on the surface. That's just weeds.